I can do that for you. Let's see, where's your name at there? Let's see, 3 dots, make host. All righty, all yours.
There's everything ready for me to go. Good. We'll wait about 4 or 5 more minutes to get everybody checked in. It's going to come in and we'll get started.
Sounds good. Yeah, hopefully here we'd like to within the next 6 months get solar and everything on our RV. We just got to save up to get it done.
Yeah, are you going to have somebody do it, or are you going to do it yourself?
I'd like to do it myself, and either get Gary Jackson and maybe Brian Rowley and some guys that know how to do it quite a bit more than what I wouldn't want to tackle it just myself. I don't have enough knowledge in trusting myself to do it all by my own.
Yeah, and you have the channel for the wiring already, don't you?
Yeah, our RV has the channel for it. I don't believe it's pre-wired, but it does have the channel.
Well, I bet it is pre-wired. How old's your rig now? About 8 or 9 months?
Just over a year. Ours is a 19.
Yeah, I would not be surprised if it's already pre-wired.
It might be. I don't remember if they said it was the late model 19s when they started pre-model or pre-wiring them, or if it was the early 19 when they started pre-wiring them.
Yeah, an easy way to tell where the channel comes down inside of your storage bay, if there's any wires in that, you're good to go.
Okay.
I would not go up and pull the cover off the roof panel until you're ready to install.
No, because I don't want to have to reseal that before I'm ready.
Yeah, exactly.
But I'm still looking at that place that I showed you with those 330 watt panels. Of maybe going with roughly about 1,300 watts.
That's a lot of power.
Yeah, well, we'd still want to go off grid and do everything that we want to do and never have to worry about it again.
Yeah, it was really nice at the Quartzite rally this year. We were out in the desert for 14 days, and we were watching TV every day and running the furnace all night and all that. In 14 days, I never had to fire up a generator. I was recharged fully about 2 o'clock every day.
Yeah, I miss the days of having the solar on our Solitude. Even though we have a generator in the Momentum now, I miss the days of having solar and just being able to walk over and hit that button and have the entire RV turn back on and have no sound.
There's Kate checked in.
Hi, Kate.
Wave, Kate. She's talking, but her microphone's turned off. There,
Oh, look, he finally got his mic on. Been all by himself for the last 4 days.
Hi.
How you doing?
Hey, Rob.
Hey.
Rob's on here. I finally noticed Rob's on here.
Yeah. I think I've heard this before, but I thought I'd just join in. You got a bit of time?
Yeah, this is going to be a little experiment for me. I actually took my PowerPoint and added narration to it, so I can kind of sit back and relax for the first 40 minutes and be answering questions on the side on the chat box.
Now just remember, Jim, you don't have 12 hours to do your presentation.
I will try to keep it to the normal 3, Jeret.
You still need to make like a solar 101 and a 102 and a 103.
We need to get up into the 400 or the master's level for some of these people on here. I mean, a lot of these people are very knowledgeable, so
then you need to do an install, and if you want to use my RV as a demo, I'm perfectly happy with that.
Oh, I see what you're doing. In which case, if you need a reflection,
See?
if you need, in which case, if you need a reflection, we're here.
Anybody
just
with
had
an
no
umbrella?
I've got 12:01, so let's go ahead and kick this thing off. Now, when everybody checked in, their microphone should have been muted. Let's go ahead and make sure your microphones are muted during the presentation. At the bottom of the Zoom box, you'll notice that there's a chat box. If you have a question during the presentation, go ahead and type it to everyone in the chat box. I'll try to answer those in the chat session as we're going along. If not, if you have a question later on regarding the presentation, just go ahead and hold on to it. Try to remember what chart we were on. I'll go back to it and I can answer your questions, hopefully. And the presentation itself will take about 40 minutes, and then that'll give us about 20 minutes for questions and answers. Before we get started, does anybody have any questions right now? Oh, okay. My name is Jim Hinkle. I've been a grand design owner for many years. I started off in early 2014 with our first reflection model. And I retired as a electrical engineer in the tactical missile business. As you can see over my shoulder right here, here's a little model of a tactical missile that I spent 30 years building. I was working on the electronics and guidance components for those things. So I've got a lot of electrical background. And when I started to do more and more boondocking, I decided that solar really was a much more economical and feasible way to charge my batteries up every day than trying to run a generator out in the desert or up in the mountains and then making all that noise and having to have gasoline for it and all that. So I started digging into solar, and I've learned quite a bit about solar over the years. So without further ado, I'm going to go ahead and share my screen, start the PowerPoint presentation, and get this ball rolling. Okay, first question. Can anybody see the presentation? Okay, you see it. All right, so I'm going to go ahead and get it started.
Hello, Grand Design owners. My name is Jim Hinkle, and I'm a Grand Design owner myself. I'm a retired electrical engineer, and about 6 years ago, I bought my first Grand Design unit. And ever since then, I've been toying with solar power to charge my battery bank and try to go camping out in the woods without having to have a generator and all the noise that's associated with it. This presentation is designed to take about an hour and get into some of the basics of solar charging, battery banks, and some of the equipment that you need to have to successfully install solar in your coach. So why should you invest in solar power? Like me, I like to do a lot of camping off the grid. I don't like to be in a place where you're elbow to elbow with fellow RVers. I like to go out into the desert or the mountains and go boondocking, dry camping as we call it.
Did the sound go away, Jim?
An inverter is used to take battery power and power your 120 volt devices. How much solar power are you going to need to keep your batteries charged up based on your draw? What kind of equipment do you need to install for solar? Do you want to use portable panels or roof mounted panels? How do you get your try to answer these questions for you in the next hour. Before we can really get started on solar, everybody who's going to be working with it and designing their own system needs to understand a little bit of basic electronics. I like to think of a slice of pie. P equals I times E. P stands for power, I stands for current, E stands for voltage. So power equals current times voltage. Power is measured in watts, current is measured in amps, and voltage is in volts. You'll see the little triangle on the left-hand side. You see the P over the I and the E. If you know your power in watts and you know your volts, you can cover up the I, and that tells you to divide the power by the volts, and that will give you the current. you can remember this simple equation and that simple triangle, you'll be able to figure out any one of those three if you know the other two. The first step is trying to really figure out how much battery power do you need to use for your coach. Grand Design has actually made it kind of simple for us to calculate what our usage is for various devices. In every owner's manual they've published, they put a chart in there which shows the current draw for each of the types of items that you may be using, whether it's a 12-volt system or a 120-volt system. For example, if I scan down the column on the left under the 12-volt system, you'll find the furnace. The furnace pulls 12 amps per hour of usage. So let's say your overall usage in a 24-hour period is actually only 3 hours of on time. At 12 amps per hour, you'd be using 36 amps. You can go on down and you can see, for example, the TV plate antenna booster draws 1 amp. If you're watching television for 4 hours a night and you have that antenna booster on, you're going to be drawing 4 amps out of your batteries. Gets a little more confusing when you start talking the 120-volt system. For example, if you're running a coffee maker, the coffee maker will pull somewhere between 6 to 12 amps per hour. So if you brew your coffee in an electric coffee maker, and then you let that coffee maker run for 1 hour, then you're pulling anywhere from 6 to 12 amps of a 120-volt system. But if you're running off of an inverter, you're taking that power from the batteries. The inverter will actually take 12-volt battery power and convert it to 120-volt AC current. So the problem is when you do that, you need to multiply the amps drawn on a 120-volt system by a factor of 10 when you're going to be running it through an inverter. For example, that same coffee maker, which draws 6 to 12 amps per hour, will now become 60 to 120 amps per hour. The reason this is true is because your batteries run at approximately 12 volts. House current runs at 120 volts. It's a factor of 10. So you have to take any of these amp readings in that right-hand column and multiply them times 10 if you're going to be running them through an inverter. There's actually a pretty easy way to find out how much you are actually using in your coach when you're running your various devices. And that's the thing called the battery monitor. If you look at the picture on the left, that's a display from a Victron BMV 712 battery monitor. The BMV 712 is the device that I use in my coach. In fact, if you look at the picture on the right, you'll see that there's a thing called a shunt mounted up underneath my frame on my 297 reflection travel trailer. The shunt actually takes and measures the current flow that's going through the system and makes a very accurate record of it and records it on the meter, which is shown on the left. It also, this version itself actually interfaces with your telephone through a Bluetooth device, and you can get all kinds of various information from that battery monitor that you'll see in the next chart. Now this is actual data from my phone, from the BMV 712 meter that's feeding information to my phone via Bluetooth, and I went ahead and captured what I was seeing at the time. This was actually taken last January at the Quartzsite rally out in Arizona. At the time, my battery bank was at 52% state of charge. I had 13.41 volts from the battery bank. The current is positive 37.1 amps. And what that positive tells me is that the solar charging system was turned on and I was using less power than what I was actually putting back into the batteries by 37.1 amps. The power was positive 497 watts. I had consumed 145 amp hours since the batteries were previously charged. And since I'm putting power back into the batteries, I have an infinite time until they are discharged. If I was in a negative situation, say the solar charging system was turned off, then I would be seeing the amount of hours that I had until the batteries were depleted. You'll also see that there's some temperature reading on there. It was a chilly day out in Arizona in January. It was 39.2 degrees. And then over on the right-hand side, you'll see that there's a lot of status and history. This shows the deepest discharge, average discharge, last discharge. So if you're actually calculating what you need for a battery bank, if you look at your deepest discharge, then you'll know that I used 149 amp hours. I could probably get by just fine with a 200 amp hour usable system. So the next question is, if I know what my draw is, how many batteries do I need? What kind of batteries do I need for power? And how do you install them? Before you figure out what kind of batteries you're going to use, you need to understand a little bit about the basic technology. And this chart shows you that a typical lead acid battery that comes with your coach, normally provided by your dealer, is either a Group 24 or a Group 27. You can use 50% of that battery, the amp hours that are available in it, without doing any kind of damage. Figure it out like a fuel tank. And the discharge pipe on that fuel tank is right in the middle. Once you get below that discharge pipe, you need to shut those batteries down, or you need to recharge them, or you stand possibly damaging them. The next kind of battery is a little more expensive. It's called an absorption glass mat battery. And you can typically get 70 to 80% of the useful current out of that battery. The final battery on the right-hand side is a lithium iron phosphate battery. And normally on most lithium iron phosphate batteries, you can take out every bit of available power out of that battery without damaging it. Let's talk a little bit about lead acid batteries. Some of the benefits, they are very low cost. They run 90 to 120 bucks. You can only use 50% of the battery's capacity. So for example, if you have an 88 amp hour lead acid battery, you can get 44 amp hours of usable power out of that. If you go back to the chart that we had where we're showing the usage, you can see that 44 amp hours is not very much. You're going to be very limited on the devices you use, maybe just your lights, maybe a couple runs of the furnace, and that's about it. These things are heavy. A 12-volt RV Marine battery weighs about 50 pounds for a Group 27. They normally have a 12-month, some of them will have a 24-month warranty, and they can be leaked. They can leak acid. They must be vented. These things can generate hydrogen gas. That hydrogen gas can be explosive and flammable, and if you have a spark and you're not venting that gas, you could have a disaster on your hands. Another big issue with lead acid batteries is they need maintenance. They need to have the water level checked in the battery on a very frequent basis, especially if you're using them on a routine basis. Now, if you look at the chart on the left, where it shows the voltage at the very top greater than 12.6, that means that if you're measuring that battery voltage and you have 12.6 or more volts, the charge state on that battery is 100%. If you're using a voltmeter and you're checking that battery as it starts to go down 12.5, 12.4, 12.3, when it gets to 12.2, you're now at 60% of the available amp hours out of that battery. You get down to 12.1, you're now down to 50% of that battery, and you need to recharge those batteries, or if you run them down farther than that, you run the real risk of damaging those batteries. On an absorbent glass mat battery, it costs quite a bit more. They're about $250, $350 each. I've seen some lately on Amazon, which run right around $200 to $225. A 100 amp hour AGM battery is going to give you 60 to 80 amp hours of usable power, so quite a bit more than your lead acid. They are spill-proof. Now, they say that they don't vent hydrogen gas, but if you ran into an overcharging condition, rarely happens, but you could wind up venting some hydrogen gas. So I would still recommend that you keep these batteries vented. They're a little bit heavier than your lead acid battery. They weigh about 70 pounds for a Group 27. They typically come with a 1 to 2 year warranty, most of them around 2 years, and they are maintenance free. You never have to add water to them. You can't add water to them. And on the left-hand side, you'll see the same state of charge chart like we had on the lead acid batteries. 13 volts is 100%. Get down to 50%, you're at 1205. You can run down to 11.8 volts, and you're 30%, and then you need to start thinking about recharging the AGM battery. The Cadillac of batteries is a lithium iron phosphate battery. They have a pretty high cost. When I made these charts, they were around $900 to $950 each. I've seen some brands at Costco that can be on sale for down in the $675 and up range for some of the batteries that are offered there. These things are very safe. There is no venting required. Now, a lot of people think lithium batteries have a bad history and they've exploded, caught on fire. That is true, but those are not lithium iron phosphate batteries. Those are strictly lithium ion batteries. A lithium iron phosphate has been designed specifically for safety in mind. They are very reliable, very, very few problems. I've talked to the CEO of Battleborn before, and they have never had a case where one of their batteries has exploded, caught fire, or anything like a lithium-ion battery. A 100 amp hour lithium ion phosphate battery will give you about 98 to 102 amp hours of usable power. You can run them through 3,000 to 5,000 full cycles. They come with a 10-year warranty on Battleborn. And that 10-year warranty, the first 8 years are free replacement. The last 2 years are prorated. The nice thing about them is they only weigh 29 pounds. So if you're trying to keep the weight down in your RV, a lithium-ion battery is a great way to go. They're maintenance-free. Every one that's out there has some type of an internal battery monitoring system. That internal battery monitoring system will shut the battery down if it gets into an unsafe condition. If it gets too hot, too cold, one of the cells goes bad, it will monitor that battery and take really good care of it. Another benefit of lithium iron phosphate batteries is they charge very fast if you have the correct charger set up with them. They'll normally charge up in 50% of the time of a lead acid or an AGM. So if it takes you 5 hours of running a generator to get your lead acid battery charged up, you're probably only going to be looking at somewhere between 2 to 3 hours to charge up a lithium iron phosphate battery with the same kind of a converter. Now, a lot of people ask me, Jim, should I be using 6-volt batteries or 12-volt batteries? And the answer is yes. You can use either kind of a system you want. A 6-volt battery, you got to put them in pairs. You have to connect them in series. So when you're looking at 6-volt batteries and you're putting them in series, your voltage will increase when you put 2 of them together in series to 12 volts, but your current capacity is going to be unchanged. So if you have 2 6-volt batteries with 100 amp hours of current capacity, you're winding up putting them up in series, you're going to wind up with 12-volt bank, but you're still going to be at the 100 amp hours. Primary benefit is some of these batteries are built very, very heavy duty. They are very heavy, but they can have quite a bit of amp hours available for them. I've seen them all the way up into 200, 225 amp hours available. Once again, the big drawback, they are very heavy. Trying to put them into the storage area on a fifth wheel is very difficult to do because of the excess weight. And if you have them out on the tongue of a trailer, then you're going to be having a lot of trailer pin weight. 12-volt systems, you're typically going to connect those in parallel, which will increase your current, but your voltage will be unchanged. So if you have 2 batteries that are 100 amp hours and they're 12 volts, you're going to still be at 12 volts, but you're going to increase the current to 200 available amp hours. Primary benefit of a 12-volt system, in my opinion, is if one of your battery fails, you can take it out of the system, connect to the remaining battery, and you'll still have some 12-volt capability until you can get that other battery changed out. Typical drawback from a 12-volt battery is you're not going to have the same number of amp hours that you would have from these big, deep cycle 6-volt batteries. They'll all work in any kind of a situation that you want to put them into. If you want to go ahead with the like a Trojan T105 6-volt battery, by all means do so. I prefer myself to use the lithium iron phosphate batteries in a 12-volt configuration. I have 3 of them in parallel, and they give me 300 amp hours of battery power. So now that you got a battery bank, you know what you're going to be using your batteries on. How much power do you have to charge it? Primary purpose of that solar charging, get your batteries up to a fully charged state. You would like to go in at night and have your batteries fully charged up so you can watch television, or you can brew a pot of coffee in the morning, or run your lights in your furnace all night. So the number of panels you're going to need is going to depend on your solar angle of incidence. So do you tilt your panels up? So they're laying flat? What is your latitude when you're on the earth? Are you sitting in Arizona where you have a pretty direct shot at the sun all year long? Or are you up in Michigan or British Columbia somewhere where it's late fall, early spring, and the sun is way down low on the horizon? How many hours of daylight are you going to have? Do you have cloud cover typically where you're at? What about tree shading? Are you going to park in an area with a lot of trees and you're only going to get partial sun most of the day? What kind of construction will your panels have? They're going to have diodes in them that if you get a spot of shade on one of the panels, those diodes bypass that cell and allow the current to continue to flow. A good rule of thumb to have is a 100-watt panel will provide about 30 amps of charging per day in most camping situations. So in my situation, I was using 149 amp hours. If I divide that by 30, that equals 5. So I needed 5 100-watt panels to satisfy my power needs. Now I went higher than that to give myself some extra pad, and I went with 8 100-watt panels, so 800 watts total. And typically in the wintertime, I am fully charged up by about 2:30 to 3 o'clock in the afternoon. This chart shows some of the very basic components that any solar charging system is going to have. I'm going to start off in the upper left with your panel. Now, when you went to the previous chart, you figured out how many panels you need to have. You need to connect those panels through wiring to get to the various components in the system. Most panels come with a connector called an MC4 connector. And you can buy the leading ends of those connectors through places like Amazon, Windy Nation, or whatever, of the MC4 connectors that you can crimp onto the wire, so it's a direct plug and play. As we work our way down the system, you'll see that those wires are 10 AWG or 10 gauge wires. That's very typical in most solar charging systems. The next item that you'll see along the line is that orange little box, which is a fuse. You have to have this system fused in case you ever get into a runaway condition, a high current condition. The fuse will pop and protect your system and protect your coach. Then it goes into a charge controller. I'm going to talk about charge controllers quite a bit in an upcoming slide. Going out of the charge controller through more 10 gauge wire, you have another fuse going to the positive battery terminal. You have a black wire going to the negative battery terminal. And then if you're going to use an inverter so that you can power some of your 120 volt systems, then that would be connected directly to the batteries, once again, using a fuse. Now this is a very complex system. The system has all of the same components that the previous diagram had, but then it goes into additional items such as battery switches, your shunt and your meter that I talked about earlier. You'll have transfer switches so that you can transfer power between shore power and between your inverter. There are Victron inverters and chargers so that it can actually charge up your battery at the same time that it's providing power to the coach. So this is a very elegant system. The installation, how do you get your solar system installed onto your coach? Well, the first thing you have to do is if you're going to put the panels on the roof, you have to have a mounting system. Grand Design has 3/8 plywood roofing material in all of their coaches. So you can take these mounting panels and these mounting brackets and screw them directly to the roof without having to worry about hitting a truss or a stud or a raft or whatever you would prefer to call it. You can go right to that plywood roof. I would typically use about a 1-inch screw. You'll find out that there's a pretty good size air pocket at the top of the roof underneath the roof layer, and there should not be any wires or anything there. Just be careful when you're running the screw in that you don't run too long a screw and puncture something. I recommend tiltable mounts. There's 2 reasons I recommend a tiltable mount. In the wintertime, it's very nice to be able to tilt your panels and aim them towards the sun to get more power coming into them. And the second, it's very, very beneficial if you can tilt your panels up when you're washing your roof. You need to maintain your roof every 3 to 4 months, so this would be a really good idea to have a tiltable panel so you can get up there and wash it thoroughly. In this chart, you'll see some pictures of mounting configurations. This is my personal coach. You'll see in the left picture that there are, my solar panels are all tilted up. I have them so I can tilt them either way. I can tilt them to the left, I can tilt them to the right, depending on the angle of the sun. On the right picture, you can see my actual brackets that I've made. These are homemade. I went and bought the raw aluminum stock. I cut them to fit. I made them for myself. This gets them up nice and high so that I can get the wire to run underneath them. And it allows me to go ahead and tilt the panel one way or the other, depending on what my needs are and how I'm parked. Also notice that on those homemade panels, you'll see a sealant around the brackets. It's very important that you seal that roof back up when you have screw penetrations. Now in this chart, it talks about whether do you want to run your panels in series or do you want to run them in parallel. When solar first started coming out, if you ran your panels in series, you would get nice high voltage and low current, which allowed smaller wire sizes. But the problem was if you got shaded on any one panel or portion of a panel, you would lose the entire charging configuration. So So all panels pretty much went into a parallel configuration years ago. That's not so much anymore. Parallel is nice because you do have the panels that are unshaded continue to produce electricity. But the problem with that is you quite often have to run a larger wire size when you run everything in parallel. If you look at the bottom chart, this is a device called a bypass diode that are installed in most modern panels now. If one of the cells or a bank of cells gets shaded, the bypass diodes will actually shut off that portion of the cells, and it will allow power to continue to pass through from the cells that are not in the shade. So this way, you can go ahead and continue to have your power going, and you get the benefits of running smaller wire sizes, such as your 10-gauge wire. It's provided by Grand Design in most modern coaches. So how are you going to penetrate the roof? Well, if you're really fortunate and you have a recent model year of a Grand Design unit, they've thought that through for you. They now have a port up on top of the roof, which has wiring right underneath the port. It's already been drilled for you. The wire has been run down to the pass-through area typically, and you can use a wire that's already there to go ahead and wire up your system. But if you don't have that, or you have an older unit, you're going to have to figure out a way to get that wire down from the roof down inside your coach. Some people have run it through vent pipes. It'll work. It's technically a violation of the building code because you're not allowed to penetrate a vent pipe. Penetrations really should be minimized. I would make sure that you make all of your connections on the roof and then only run one set of wires down into the coach so that you're only drilling a couple holes. The devices at the bottom that you see, the one on the left is called an entry gland. An entry gland is a way to seal up the roof and run your wires in without getting any kind of rain leakage. You would put that down on the roof and you'd seal it up real good with some Alpha Flex roof sealant and make sure that it's sealed from the rain. The device on the right-hand side is a combiner. For example, that is what's called a 3-in-1 combiner. You can take the output of 3 panels in parallel and then have it combined into one outlet so it can run down in through the gland, the solar gland. Now, this gentleman named Brian Rowley, he actually removed the bathroom wall in his 337 to run the wiring down through the back wall. It's a really simple process. The panel was stapled up onto that framing that you see there. We pulled it off, ran the wires through, ran them down in, and put the panel back up, and it looked like it was brand new, and the wires were not exposed. If you're going to be drilling through your roof, if you have an older unit that doesn't have the Grand Design equipped panel entry, a wire entry, then the next thing you're going to want to do is drill your own holes through an accessible area. This is in a closet of my coach. Now you can see that device I'm using there. I plugged into shore power and I'm probing around that roof to see if that lights up to show if there's any shore power cables running through that roof, any 120 volt wires. And you can see it's lit up. I've got wiring right there, so I can't drill right there. The picture on the left is how I penetrated into my 297 RSTS. I drilled a hole right there through the middle of that closet. That's a closet for a washing machine. Drilled a hole, ran it down the back of the wall right there, and down into some drawers underneath that you can see on the right-hand side. Ran it down in there. I put a loop of wire in there for some extra service capability, and then ran it out through the frame and then up to the pass-through of my travel trailer. So now that you have your panels on the roof, how do you safely get that solar generated voltage down to the batteries? Talked earlier about the type of solar controllers that are available. The oldest version that's been around for many years is called a pulse width modulation solar controller. PWMs are very cheap, but they are not very efficient. They've been around for a long time. They're very inexpensive. You can get them in a range of voltages like 12, 24, 48 volts with current ranges of 5 to 60 amps. Simple to maintain. You just mount it up. You put your fuse in your line. You run the wires into the controller. It's good to go. There is a lot of efficiency loss when the batteries are at a low voltage. You may be limited on system growth. Say you want to add some more panels in a later time. You've got to go ahead and probably update your controller. Now, this red note in the bottom, you have to use a charge controller in your system. If you just run the solar voltage right into your batteries, you're going to damage your batteries, maybe even cause a fire. You need to be really careful to make sure that you always have some type of solar controller. Another controller that you can use, and this is the one by far used by most installers now, is an MPPT, or Maximum Power Point Tracking Controller. A little more expensive than PWM, but they provide much more efficiency over a PWM controller, typically about 30%. You can get them with capabilities of up to 80 amps, and you can have them with much higher voltage banks than a PWM controller. Normally, they'll have a longer warranty. They're very flexible if you want to expand the size of your solar charging bank. You quite often can get by with the same controller that you use for 4 panels. You might be able to get 6 panels onto it. The cons of an MPPT controller, they're more expensive. They're generally quite a bit bigger than a PWM controller, and they're a little more complex. Sometimes it's a little difficult to get them installed and get them programmed correctly. But with enough research and a good set of instructions, you should be able to figure it out. Now, my MPPT controller I have from Victron actually has a Bluetooth capability on it, like the battery monitor does, and I can get some very useful data out of the Bluetooth feature on that controller. For example, this is a snapshot once again from January out in Quartzsite. My solar array was putting out 325 watts. The solar array had 72.66 volts, and the current out of the array was 4.5 amps. At the controller is converting that 72.66 volts down to 13.69 volts, and taking that 4.5 amps of current and converting that to 23.3 amps of current going into the battery. So you can see this is very efficient. 4.5 amps in, 23.3 amps to the battery itself. I was in a bulk charging mode. The chart on the right, you can see the last 30 days of usage out of my controller. Now, around December, late December, I was using it just a little bit out in our property and not having a big demand on it. But you can see starting right there on January 1st, there was a big demand, and that demand was when we went out to Quartzsite. Lots of usage and lots of power coming into the system to keep my batteries topped off. I'm going to show some example systems to achieve the same goal. Now, I showed you a basic system, a very complex system on the diagram. These are some of the basic systems that you can get out there right now. A portable charging system. The one on the left is a 95-watt Furrion panel. It connects to an input port that was put on older Grand Design units. Not so much anymore. Now the Grand Design is going more with the roof-mounted panel operating systems. They did not put the Furrion port on the side of a trailer. You can still buy the port so that you can plug this directly in. But the Furrion panel is about $500. It's a really nice panel. We have one in the family, and it works very well, but it's only 95 watts, so it's not going to give you a huge amount of current to charge your batteries. You can go buy a 100-watt HQSP panel that connects to the input port with an adapter for about $190. So it's a huge savings over Furrion. Both of these portable panels have a built-in controller. Typically, it's a PWM controller on these, but this will allow you to provide the power to your battery without damaging them. This is an example of a moderate charging system. It might meet quite a few people's needs. This is off the roof of my 2017 290. Uh-oh. This is an example of a moderate charging system. It might meet quite a few people's needs. This is off the roof of my 2017 297 RSTS before I upgraded the system. You can see that there are 3 100-watt panels. The wiring is routed up to the front, right in front of that skylight, down into that closet. That white small device right in front of that skylight is a solar gland. So that keeps the water from getting from the roof into the inside of the coach when I run the wiring in. Over on the right-hand side, you can see that large white device with all the ribs on it. That is my MPPT controller. It was a 40-amp MPPT controller. The black box just to the left of that controller is the programming device that you can use to program the controller for different types of batteries, different current flow, selected voltages, so that you can set it up, customize it for your particular needs. Right below that black meter in the white box, that is the battery meter, the Victron battery meter. That's where the Bluetooth capability comes into play. This is an actual display that you can look at, or you can Bluetooth it to your. This is an example of an intermediate system. This is the same Traeger that I showed in the previous slide. This is my 297 RSTS. I've gone from 3 panels on the roof to 8 panels on the roof. Each one is 100 watts. I have 4 panels in series, and I have another 4 panels in series, and those are combined through that connector right by that skylight and vent to put those into a parallel situation before I run them down through the solar gland, which you can see is that white box with the wires going right into it. Over on the right-hand side, I've upgraded things a little bit. I still have the battery monitor in the lower left. Right next to that, I have a circuit breaker. So instead of using a fuse to protect the system from coming from the solar arrays, that's where my solar array comes into a circuit breaker box, which then goes into the MPPT controller. I'm using a Victron Energy MPPT 15060. It's a rather expensive controller, and Victron has a page set up where you can put all your inputs into it, and it will tell you the correct controller to use. Coming down from that, I actually have a shut-off switch. You can see that red switch right there, which will shut off the power to the batteries if I want to shut off that flow. So I can shut off the controller by either shutting off the circuit breaker on the left side, and I can shut off the flow to the batteries with the switch on the right side. There's also a fuse between that switch and the batteries, which is actually down underneath the Traeger. Over on the far right-hand side, you can see that I still have that 2,000 watt inverter. It works very well for me. The fuse is just underneath that on the left side, and there's another shut-off switch for the actual inverter. Now we're getting into this complex system. Doug Myers, you can see every one of those is a Battle-Born battery. You can see that he's using multiple MPPT controllers. If you had one big controller for a monster system, it would be very expensive. But by breaking it up into 3 controllers and running those different controllers down to the batteries, he's wound up with a much more efficient system. Over on the far side, on the other side of the batteries, you'll see some of the different devices that you can use to run as an inverter, as a charger for your batteries when you run shore power. A very complex system, very well thought out, very well designed and executed. Over on the right-hand side, you'll see many, many panels on the roof of this unit that belongs to Joey Carson. Beautiful job. You can see the wiring is very clean and neat, not very exposed at all. And those are tiltable panels. If he needs to tilt the panels up, he most certainly can do so. So other equipment that you might want to use, an inverter, a converter, an inverter charger, a pigtail, transfer switches. Let's talk about some of those. So first of all, our inverters. If you're going to be running 120 volt systems inside your coach and you don't want to run a generator and you don't have shore power, a way to do that is through an inverter. Over on these inverters that you're looking at here, on the far left is a Magnus sign inverter. Very, very expensive inverter, but it does a great job with very clean power. The one in the middle is a 3,000 watt inverter, very typical for a standalone device. And the one on the far right is one that you can actually clip to your battery terminals or plug it into a cigarette lighter and get a little bit of power out of it. That might be fine for running a single television or something small like that. It's very important when you're selecting an inverter, if you can do it and your budget can afford it, is to go with a pure sine wave inverter instead of a square wave or a modified sine wave inverter. This will make sensitive components such as television, stereo system stuff run much smoother if you have a pure sine wave. There are inverter chargers available too that have internal transfer switches. That MagnaSign is typically an inverter charger, so you don't have to have a standalone converter charging your system up. Now that you have an inverter installed, how do you get that power to your outlets? Well, the simplest way to do it is to take an extension cord, plug the device you want to run into the extension cord, plug the other end of the extension cord into your inverter, and you have power. Very simple, not very elegant. They'll have cords that you need to deal with so that you don't trip over them. Another way to do it is to have a dedicated outlet. So you'll run wiring from your inverter to an outlet through a junction box, a duplex outlet. That way the wire's up out of the way, stapled correctly or run correctly so that it's not in your way. And then that outlet becomes a dedicated outlet specifically to run off your inverter. Works real well like if you're going to run a television inside of a bedroom. Another way to do it is to use a pigtail like the one you see on the left-hand side. You plug that into your 50 amp inlet on your shore power, and then you plug your extension cord into the 15 amp duplex plug right there and run that in your inverter. That's great. It will now power every outlet inside your coach. So if you want to use one outlet for a coffee pot, or you want to use an outlet for a television, or for a computer to charge your laptop up, this will do it. You need to make sure that you don't overload your inverter. So for example, if you have a 2,000 watt inverter, you don't want to be using more than 2,000 watts of power. One caution on using this method: before you plug the extension cord into the inverter and turn the inverter on, you need to go inside your coach into the breaker box, and you need to turn off the breaker for the converter. If you don't do that and you turn your inverter on, the converter is going to be trying to stuff power back into the batteries. The inverter is going to be pulling it out. It'll get into a vicious cycle and run your batteries down very, very quickly. It's not a good thing to do. You need to make sure that you're on top of that. The next way to make that power run is to use an item called a transfer switch. Transfer switch takes two power sources and turns whichever one is the dominant one on when it needs to. For example, if you plug into shore power and you have a transfer switch, that transfer switch is always going to be dedicated to pull the shore power first. If it loses shore power, you unplug, or there's a power failure and you have your inverter turned on, then the transfer switch will select power from the inverter to provide power to the coach. So you can set it up to find out which one is going to dominate the transfer switch. They also sell transfer switches that have 3 inputs. So you could have shore power, you could have your inverter, or you could have a generator. Very expensive, quite complex wiring to do that. Once again, even with a transfer switch, you're still going to have the converter turning on. So you'll need to make some changes to your wiring. You need to put a relay to shut your converter off, or you can go and install a separate set of circuit breakers that will allow you to have just certain dedicated circuits powered on. Now, these are different examples. One is from Marie, Chris, and Lance. You can see the different setups they use, where they use an actual sub-panel to run power to the desired areas where they want to have power from the inverter running. So when you're on shore power, these items will provide power from shore power. If you go to the inverter, the transfer switch will flip it over. The power will still come into this transfer box and go to where it needs to go without running your converter. So now that we've gone through some of the basics on what solar charging is and how to put a system together, where can you get help? Where can you get your questions answered? The #1 place that I recommend is Grand Design's technical forum. Grand Design owns this forum. They put a lot of time and effort in putting this together and staffing it with knowledgeable people. Grand Design employees actually participate on this. There are a half a dozen moderators on there who have received special training from Grand Design to help answer any kind of a technical question you have, whether it's solar or any other technical aspect. Facebook, there's a group called Solar Power Grand Design. You need to be a GDRV owner to do that, but go ahead and sign up for Facebook if you like to use Facebook. There are some commercial resources out there. WindyNation.com, BattlebornBatteries.com, and VictronEnergy.com all have really good resources online to help you design your system. So I've used a lot of terminology in this presentation, and some of the times that terminology can get a little bit confusing. So I've tried to capture some of the major ideas on this chart. Please use it at your leisure to try to find out the answers to questions you may have about different terms being used. So in concluding the presentation, hopefully you've been able to figure out a little bit about how to determine what size battery bank you need, what kind of batteries you're going to use. If you're going to put solar panels on the roof, how many do you need? What size do they need to be? How do you hook them up? How do you run the wires down to your controller? What kind of equipment do you need as a bare minimum? Where can you get information? Can you do it yourself? I think most owners, if they have some technical ability, can put these systems together themselves. And hopefully I've given you places where you can turn for help. You can always contact me. My name is Tucson Jim on the Grand Design Owners Forum. Send me a private message, post your questions in the public forum, and many of us will try to jump in and answer them for you. Take care and good luck.
Okay, how was that? Oh, everybody's muted.
Good information.
Unfortunately, I saw all of these questions popping up, but when you're in the presentation mode, it would not let me read the chat boxes. So I'll try to go through some of these questions right now and answer them. So the first one says, that looks like an SM2 from Dennis O'Brien. Yes, it is. That's a Standard Missile 2. Not related to solar, but that's what that little missile is right here. Let's see. I really like the batteries.
What's the next
Great.
one?
Battleborn batteries are the best. Read. If you have this is from Donna and everybody. If you have a rooftop system, can you use a portable system as well? Absolutely. No problem whatsoever.
Is there anything you have to do to make them both work at the same time, or is it just
as long as your portable system is wired down to the batteries, and it should have a fuse in it? If you have the Furrion setup,
we do.
it should have the correct wiring going down to the battery, and it has a fuse installed inside your coach. Just plug that Furrion panel in along with your other one. Both controllers will work together to make sure your batteries are charged. So say, for example, all your roof mounted was in the shade, and you had that little portable Furrion panel and you moved it out into the sun, that Furrion panel is going to work just fine.
Okay, I have a second question.
Okay.
We have 3 panels. We're doing well with solar. My question is, where does the transfer switch fit into the wiring diagram?
Oh, yeah, electrical and then the maintenance.
Okay, so a transfer switch, this gets a little bit more complicated, and probably something we'll have to take offline to look at your specific coach. But normally a transfer switch will be installed where the shore power comes into it on one side. You'll have either your your inverter power coming into the other side of the transfer switch. And then from there, power goes out just like it was continuing the pathway into your circuit breaker box.
Okay.
So once it gets to the circuit breaker box, if your converter is turned on, then you've got to manually shut your converter off. The other option, which I tried to show in those slides, is to put a sub panel in, take all the wiring out of your circuit breaker box that would normally be the outlets that you want to power from the inverter, and then power those up with the through the transfer switch. So it's a break in the circuit, and you're taking things out while you're on the inverter, like your converter and maybe some other outlets you don't want to use. A lot of people don't like to wire the air conditioners in. They don't want to run an inverter. They don't want to run an air conditioner through an inverter. So those would not be included in that sub panel.
Mm-hmm.
Okay.
Howard put a note down there. It says some inverters double as a converter too. That's what I was trying to show on that MagnaSign inverter. That MagnaSign inverter also can be an inverter charger. And I'm sorry about shutting the audio off in the middle of the presentation. I didn't realize if I shut my microphone off, it would kill the audio on the slideshow. Any other questions?
You need to be a rocket scientist to hook this thing up, it looks like.
No.
Just a rocket scientist to hook his system up.
Yeah.
Hey, Jim, I got one question for you. If you've got your solar panel hooked up as a portable one, is there an issue if you start your generator, or do you need to disconnect it?
I'm sorry, I'm having a problem with your audio. It sounds like you're a long way away from your microphone.
I'll lean in. My question is if you've got your portable solar panel connected, is there an issue if you start your generator?
No, you can be running both the solar and the converter at the same time. Won't hurt a thing.
Okay. So the
same question. If you have your solar turned on and you're plugged into shore power, they're both going to be charging the batteries up.
Okay, so it's not an issue for a conflict.
Not at all.
Cool. Thank you.
Any other questions? Okay, so Dennis O'Brien says, can the average RV dealer install a system like yours, or should I look for an RV solar specialist? The answer is it depends. There are some dealers that I've seen that do a very, very thorough job. They know what they're doing. They have technicians that have done this over and over again. I think you're going to have to ask your RV dealership if they have experience in doing it, or if you should go to a private installer. Other questions? Jeret, I'm going to let you, I'm going to turn the hosting back over to you. Or do you do that yourself?
Nope, you would have to do that.
So I click on you.
On over my video part, the little three dots, right click on that and then go to host.
It's already done.
Oh, we got another question. Dennis is wondering where you'd find a private installer.
I would suggest that you get on that technical forum, gdrvowners.com, and ask that question in there, because you're going to have people from all over the country who have used installers in various ways, shapes, or forms, and get some personal recommendations on people that they've used. Some may be, really experienced and do a great job, and other ones may have other issues. Okay, I think it's critical to understand the concepts before hiring anyone. Absolutely. Howard just made a point to, understanding this chart, asking questions on the forum or the Facebook solar power page. Understand what you want somebody to do before you pay them to do it. They may have their idea of what they think you want, but it's much better off if you have at least some basic knowledge before you start to proceed and hire somebody.
Do you got any recommendations on the type of panels that should be used? When I've looked them up, there's a ton of manufacturers out there. Some say they're specific for RVs. Some people say you can use residential panels if you have enough room on your RV.
Yeah, so one of the first things, I should have brought this up in the presentation, I'll have to add that. I never, ever, ever recommend using foldable or flat laying panels on the roof. You have to glue them down. They only last a year or two, and they don't hold up. All the panels should have some type of it should be a glass type material, an aluminum frame. Those seem to hold up the longest. I've never really heard of a person having anything get broken up there. And if it does, it's easy to replace one panel. Grand Design right now is putting a 300-watt panel in their complete turnkey solar charging systems. That is a really, really nice panel. I'll get the details off of that. I got a picture that I took when I was in the factory the last time of those panels, and I'll send it to you, Jeret, so you can post it out on the rally page.
Okay.
And let me go down through high-tech solar. Okay, so Joe said he recommends high-tech solar panels made in the USA. Can't go wrong with that. Zamp is another good brand. Neil said he's had good luck with high-tech. Brian, how does the battery react to two charging systems, shore power and solar and generator? The battery won't react any differently. What's going to happen is one of the charging systems is going to see a higher voltage when the other charging system is running. So it will throttle back. Primarily, one of the charging system is going to take a dominant role. For example, in mine, if I had the solar turned on and I had shore power turned on with my shore power lithium dedicated charger, it's going to take priority because it's going to put in the 14.6 volts and the high current needed to charge the batteries. So my solar charging controller, the MPPT controller, is going to see that that's already up to voltage, and it's going to back off.
Yeah, that makes sense, actually. Yeah, this is actually pretty good.
Couldn't hear you. Yeah, Neil makes another good point. He says you could have more than two. You could have shore power. If your truck was running, the truck would be charging, the solar would be charging. That was one of my big concerns when I first got started on this too. And I've like Howard says, It's become transparent. It does it all on its own. So Howard made a comment there for everybody. Howard, you want to weigh in on that? You'll have to unmute yourself.
I'm sorry, on what, Jim?
On that one, we said where you made a map of your roof and configured it based on the side of the panels. If you want to weigh in so everybody can hear that.
Yeah, I actually went up and took pictures of the roof and stitched them all together so I could see exactly the size. Because not all solar panels are the same size as far as width and length. So I actually made size, gosh, which word I'm looking for, that the dimensions that they were represented what the panel would actually look like on top of the trailer, and configured the panels, quote unquote, and figured out which panel I could get the most on top of my roof on my 315 RLTS. Does that make sense?
Oh, kind of like a mock setup.
Yes, that's exactly what I did. In fact, if you want to see that, just post a question on the forum that Jim has mentioned, the Grand Design Owners Forum, which I'm a moderator with Jim as well. And I've got a specific post which shows all the different panels that I went through as I tried to decide which one to use. I think, Jim, you and I both ended up with the Renogy 100 watt, didn't we? Isn't that
yes.
Well,
yep. That's what I went with.
Yeah, I ended up with the Renogy 100 watt as well, because I figured out, based on their physical size and all the different obstacles that are on the roof between the air conditioners, the vents, the TV antenna, all the different things that are in the way, that those Renogy 100 watt panels actually, as I got them on the roof, I could get the most of those panels based on their size.
By the way, to add to the GDRV owners technical forum, it's nice to see that on here I'm not sure where Rob just went. Rob, there's Rob. Anyway, going along the list here, you've got Brian Cravener, Brian Wave, there's Brian, Howard Wave, and Rob Wave. So the four of us are the original moderators on that technical forum. We've been to Grand Design, received some of their technical training along with Lippert and other companies. You get some of their technical training. So we can kind of answer some of your questions and take the load off of the Grand Design customer service department, or answer your questions after hours or on weekends. So by all means, please feel free to hit us up. There's a lot of very experienced people on that site. I see that Neil Citro's here. Neil is a very frequent contributor and a very helpful resource on that forum also.
Neil needs to turn his video on.
Oh.
There you are. All right. Hey, Neil. Good to see you.
Hey, Jim, I have a question that's not related necessarily to solar. The batteries that came with our 337 coming up, you were talking about Battleborn batteries earlier, and I just wasn't sure which model of Battleborn batteries I would need to replace with, the 100 AH, 50 AH, or what the difference is.
I would strongly recommend the 100 amp hour batteries. They're running around 925 right now. Every once in a while, they might have a sale. Sometimes they have rally sales. Keep an eye out. You know, it's a big investment to go out and spend $1,000 on a battery, but that battery is going to last you 8 to 10 years, if not longer. And the reduced weight and the usable power that you can get out of that battery. One Battleborn battery giving you 100 amp hours of usable power is pretty much the equivalent of 2 standard 12 volt batteries that you have now. So in my 3 batteries, I would have to have 6 12 volt lead acid batteries to equal the power that I get out of 3 Battleborns.
Okay, so I could do with just one then, and instead of the 2 that I currently have.
Yeah, as long as you're not out, you know, boondocking and trying to draw a whole lot of power out of it, one will be just fine.
Yeah, we don't boondock. I have a hard enough time walking on level surfaces.
One will be great.
Yeah, every word is true.
Howard, you might want to weigh in. There was a guy in the chat asking about the DC to DC charger and the risk to the inverter.
I couldn't hear the question.
Oh, sorry. Can you hear my sound now or no?
I hear you, but it's like you're quite a ways from the mic.
Yeah, I have a complicated setup going on. There's a guy in chat asking about the risk to the inverter with lithium batteries, or the risk to the alternator in the truck with lithium batteries.
Oh, okay. That's true, especially if you're using a DC to DC converter and the lithium batteries get really discharged. It'll try to pump a whole lot of current in real quick, which could overrun the alternator. Typically, if you're just going through the 12-volt line, it's not going to allow that much current to flow. It's something you definitely need to consider. With my solar charging system, I never let the batteries get that low in the first place that when I hook up the truck, it's trying to charge 300 amp hours worth of battery power.
Yeah, I had once discharged mine down pretty far, staying in someone's driveway. And when I left, it was cloudy, so my solar wasn't doing anything. So all my charging came from the truck. And even then, I was still only pulling like 7 amps out of the truck. The truck seemed to be regulating it, so it wasn't a problem. But I have heard that can be a problem.
Yeah, Howard has a DC to DC converter in his. So
yep,
he could be pulling a whole lot of power real quick if he had really discharged batteries.
But the trucks typically limit that way down. What did you say yours was pulling, Neil?
At max draw, I think the most I've ever seen out of it was like 8 amps.
I know, that seems to be pretty standard. The trucks, people are fused with 40 amp fuses. They don't put out more than 10 amps to the trailer.
Yep. I don't know if it's something in the computer or the truck or the wire size they use or what, but can't get hardly anything out of it. So I'd put the same DC charger in that Howard's got. And it charges at 40 amps, and I get 40 amps out of it right on the nose.
Brian brought up a good point. You were asking about going from the 2 lead acid batteries to 1 lithium battery, that you should change your converter charger. It's not necessary. Battleborn says you can stay with the same converter that you have, the same battery charger that you have. It will take longer to charge that lithium battery up. And if you're not trying to get it charged very quickly, you can stay with your current WIFCO converter. It'll work just fine. If you do want to charge as fast as possible, then I would recommend going to a lithium dedicated converter to make that happen.
I could just say as a side, I have the Magnasign, and while it's not lithium specific, when you get to that level of inverter charger, its charging profile is programmable. So I essentially just programmed it to be a lithium charger then.
Very good. I think we're about out of time. Any further questions before we start to shut it off? Hey, thank you all for joining today. I'm going to hand it over to Jeret, and he'll let you know what the next meeting is.
All right.
Thank you.
For everybody coming out. Thanks, Jim, for a great presentation and bringing your entire crew or the entire crew of the forum on here. It's great to see all you guys together. I don't think I've seen all you guys in the same place since the last meeting that we were in back in Indiana. So.
Oh, by the way, there are 2 other moderators. There's Michelle and Andy. Michelle is closely related to Brian right there, like the missus. And then Andy is somebody that we've added in the last year.
I have not met them then.
You haven't.
They weren't part of it last time. Well, we got to start getting.
There's Michelle right there.
I've talked to her before, but I have not. Well, no, we did meet her that one time, that last one. So our next seminar is going to be starting in roughly about 25 minutes. It's going to be with Mike Despain. He's going to be going over the electrical systems on the RV and what we can do not to blow up our RV and electrocute ourselves. And oh, here comes either his wife or himself logging on as his wife. So let's see when that picture, we should all just shut our video off like we're not here. Let's see if it's actually him. Nope, he's not going to turn his video on. Nope, he's just waiting. So we'll see everybody again here in roughly about 25 minutes for the next seminar.